Welcome back to section 1.8, part 2. We're talking about composition of functions. Now we do have some new notation as opposed to algebra 2. So we use f, and that little dot there, the open circle, means of g of x. And there's the old notation written as well. Now, composition of functions is all about substitution. We're substituting that inner function into that outer function. So when we talk about the domain, it has to be in the domain such that it's in the domain of the inner function and the final function as well. We'll be talking about that as we go through. Remember, our two domain restrictions: we can't divide by 0, and we cannot take the even root of a negative number. So for problem 3, f of g of x. In old notation, it was f of g of x. I kind of like older notation a little bit better sometimes. So that's going to be f. Now instead of writing g of x, it's 2x plus 1. Like I said, this is all about substitution. So what we see inside, we're going to put that in place of x in function f. So it's going to be, instead of writing x squared, I'm going to leave a blank, squared plus 2 times blank. Now what we're substituting in that space is what's on the inside, 2x plus 1. Now, for 2x plus 1 squared, we have to square it properly. If you need to, write it off to the side. So we multiply and combine our like terms. We get 4x squared plus 4x plus 1. Plus, and now we distribute the 2. 4x plus 2. And then we combine our like terms. We get 4x squared plus 8x plus 3. That's f of g of x. That's our composite function. Now it says find the domain. Now we look at our inner function, 2x plus 1. There are no restrictions. And for our outer function, there's no restrictions. So our domain is all real numbers. Or, in interval notation, we're going from negative infinity to positive infinity. For part B, we're going g of f of x, or g of f with the little open dot of x. So it's going to be the function g of x squared plus 2x. It's all about substitution. So in function g, it's 2 times x. Instead of writing x, I'm going to leave it open with some parentheses, plus 1. In that open spot, we're substituting f of x. So it's x squared plus 2x. So we distribute our 2. We get 2x squared plus 4x plus 1. That's g of f of x. That's our composite function. It's all about substitution. Now, we want to look for our domain. Look at the inner function. No restrictions for x squared plus 2x. No restrictions on that final function, so our domain, all real numbers, negative infinity to positive infinity. Now, for the next set of problems, f of x is x plus 2, and g of x is 4 minus x squared. We're going to do the same thing as we did. So here's our old notation, f of g of x. I think this makes it a little bit easier to substitute in. So it's f of 4 minus x squared. So function f is x plus 2. So instead of writing x, I'm going to put my grouping symbols, leave it blank, plus 2. And we substitute 4 minus x squared. So it's 4 minus x squared plus 2, which is the same as negative x squared plus 6. That's f of g of x. Now for our domain, we look at the inner function first, no restrictions. Outer function, no restrictions, so our domain, all real numbers, negative infinity to positive infinity. Now, in part B, we're finding f of g of 2. Here, our input value is 2. Now, we found f of g of x in part A. So from part A, f of g of x is negative x squared plus 6. So what we're going to do is we're going to put in, for f of g of 2, we're going to put our 2 in place of x. So it's the opposite of something squared plus 6. So instead of x, we put our 2. Order of operations, exponents, so 2 squared is 4 times negative 1, so it's negative 4 plus 6. So we're going to get f of g of 2 equals 2. That's our function. Now for that problem, since we were only given a specific value of x, our domain is just that input. It's just going to be the number 2. For part C, we have g of f of x. Doing the same thing, we're just kind of switching them around. So it's going to be the function g at x plus 2. Now the function g is 4 minus x squared, so it's going to be 4 minus, leave it blank, something squared, and in that opening you put your input, x plus 2. Now remember, be careful when you square your x plus 2, it's x plus 2 times x plus 2. So it's going to be 4 minus the quantity of x squared plus 4x plus 4. Distribute your negative 4 minus x squared minus 4x minus 4. So when we combine our like terms, we get negative x squared minus 4x. The 4's cancel. And that's g of f of x. For our domain, no restrictions on the inner function, no restrictions for our final function, so our domain is negative infinity to positive infinity. For part D, we're just using that function and using the input of negative 3. So from part C, it's going to be the opposite of negative 3 squared minus 4 times negative 3. Negative 3 squared is 9, times negative 1 is negative 9, plus 12. So g of f of negative 3 equals 3. And once again, our domain, we're only looking at a specific value of x, so it's going to be negative 3 inside the brackets. For part E, f of x, here it's just a function of itself. So it's the function f at x plus 2. So we evaluate the function. Instead of writing x, we'll just leave some grouping symbols and some space, and then plus 2. Now we replace inside the parentheses what we had inside the parentheses, the x plus 2. So it's x plus 2 plus 2. So f of x is x plus 4. So our domain, no restrictions for the inner, no restrictions for the final, so our domain is all real numbers, negative infinity to positive infinity. G of x. So the function g, 4 minus x squared. So it's it's g of 4 minus x squared. So it's going to be 4 minus the quantity of x squared. So instead of writing x, we're going to put 4 minus x squared. That's what we're substituting. Careful once again. 4 minus x squared is 4 minus x squared times 4 minus x squared. So you multiply that, you're going to get minus the quantity of 16 minus 8x squared plus x to the 4th. Distribute your negative 4 minus 16 plus 8x squared minus x to the fourth. So when we combine our like terms, we get negative x to the fourth plus 8x squared minus 12. And that's g of x. To find our domain, look at the inner function, no restrictions. Look at the final function, no restrictions. So our domain is all real numbers, negative infinity to positive infinity. Problem number 5. Doing the same thing, except we're going to add some domain restrictions now that we have to work with. We're going to find some numbers that don't work. So for part A, f of g of x, so it's f of 3 over x. So it's 2 divided by the quantity of, now we'll put our x there, leave it blank, minus 1. And in that open spot, that blank, where x was, it's going to be 3 over x. A little bit trickier because we're working with fractions here, so it's 2 over 3 over x minus. Now we need a common denominator. That 1 is over 1, so we're going to multiply by x over x minus x over x. So it's going to be 2 over 3 minus x over x. Now we don't divide fractions. We multiply by the reciprocal. So 2 in the numerator stays the same, times the reciprocal of 3 minus x over x, which is x over 3 minus x. So we do that, we get 2x over 3 minus x. That's f of g of x. Now we have to look at our domain. For our inner function, you can see it's 3 over x, so x cannot equal 0. So that's one restriction. If we look at our final function, we have 3 minus x. So set 3 minus x equal to 0. Add x to both sides, you get x equals 3. So x cannot equal 0 and x cannot equal 3. That's the only two numbers we can't have. So if we look at our number line, we have a 0 here. We have a 3 here. So put an open dot at each one. Everything else we can use. So our domain has 3 intervals. Our first interval is from negative infinity up to 0, and we can't include the 0. The union of our middle interval, which goes from 0 to 3, both in parentheses. And our final interval goes from the union of 0 to positive infinity. That's the domain for this function. A lot more complicated than it has been for the previous problems. Let's look at g of f of x. So for g of f of x, it's going to be g of 2 over x minus 1. So the function g is 3 over x, so it's 3 over, now what's inside the parentheses is 2 over x minus 1. Once again, we don't divide fractions, we multiply by the reciprocal, so it becomes 3 times the reciprocal of 2 over x minus 1, which is x minus 1 over 2. You can put that 3 over 1 and just multiply. We get 3x minus 3 over 2. That's g of f of x. Okay, so looking at our inner function first. We're dividing by x minus 1. X minus 1 equals 0, so x equals 1. That's a value we can't have. There's no restrictions additionally for that final one. So if we think about our number line for our domain, we have a 1 and we have an open dot. That's the only number we can't have. We have everything to the left, everything to the right we can use. So our domain, we go from negative infinity to 1 with a parentheses, and union of 1 to positive infinity. That's all real numbers except x equals 1. I'm going to stop there for this, and I'm going to do more examples in the next video because I think composition of functions is something that usually causes some difficulty. So I think it's beneficial to do one more video, especially if people are still having questions. Okay, thank you.